So thermal physics assignment, first one, that is question one. Mixture of oxygen gas and a nitrogen gas is kept at room temperature. So both have the same temperature. Oxygen molecules are massive compared to nitrogen molecules. Which of the following is a correct statement? So how to identify which one is the right statement or the correct statement? Because if they have the at the same temperature, so means the kinetic energy will be same. And kinetic energy is half mv square. Because the oxygen molecules are massive, so they have more mass, so oxygen molecule will move slower. Where nitrogen molecules are lighter, so their mass is small and they will move at a higher speed. So when we check the mean, like the option A is mean velocity of oxygen molecule is greater. That is wrong. Oxygen molecule velocity will not be greater, it will be smaller. The mean speed of oxygen molecule is same. It won't be same because they have different masses. That's why the speed cannot be same. The average or the mean kinetic energy of oxygen molecule is greater. It won't be greater. Why? Because if they're at the same temperature, they should have the same kinetic energy. But the mean kinetic energy of oxygen molecule is same as the kinetic energy of nitrogen molecule. That's why option D will be the valid answer. The question 2, a gas consists of a mixture of nitrogen and oxygen. Oxygen molecules are more massive. Which of the following statement is correct? On average, all molecules have the same speed. They cannot have the same speed as they will have the same kinetic energy. When kinetic energy is same, the product of half mv square will be same. If the particles are massive, they will move slower. Particles are lighter, they will move faster. On average, all the molecules will have the same kinetic energy because we have a mixture, so they will have the same kinetic energy. That's true. On average, nitrogen molecule, because if the kinetic energy change, the temperature will also change. But we have a mixture of the gas, so they should have the same temperature. So C cannot be an odd. Our average speed of nitrogen is less. So nitrogen is lighter, they will move faster. That's why B is the valid answer. So for this question, we have an ideal gas which is maintained at constant temperature. So if we keep the temperature constant, means we are applying a Boyle's law. And when we are applying the Boyle's law, according to Boyle's law, the pressure and volume are inversely proportional. That's why option C is a valid statement. So the brass ring and the gold ring are supplied with the same amount of thermal energy. So if you are supplying the same amount of energy, so energy of the brass will be equal to energy of the gold. Energy is equals to Cm delta T, so specific heat of a brass, the mass of a brass, and the temperature change of the brass. Where specific energy of the gold is equals to specific heat of the gold multiplied by the mass of the gold multiplied by temperature change of the gold. When we substitute the values, they mention the brass ring is having a half of the mass of the gold. So it means this is m by 2. And so if this is m, this will be m by 2. And the specific heat capacity of a brass is 3 times. So it means this specific heat is 3C. If this was C, this will be 3C. And we need delta, the brass and the gold. So when we simplify, m will cancel with m. C will cancel with C. So we are left with 3 delta, the brass divided by 2 into delta theta of the gold. But we need the ratio of brass, the temperature change. So it will be temperature change of a brass divided by temperature change of the gold is equals to 2 by 3. That's why B will be the right statement. For this question, when a liquid is heated to its boiling point, when we convert liquid into gas or a solid turned into a liquid, There's no change in temperature. The temperature does not change. Temperature remains constant. And we know temperature and kinetic energies are directly proportional. So what will happen to average kinetic energy? The average kinetic energy does not change. It will remain constant. But what happened to the potential energy of the molecules? Because when we supply heat energy, the liquid turn into gas, so molecules move away from each other, so average potential energy will increase. That's why C is the valid answer. So the average kinetic energy of the molecule is proportional to temperature in Kelvin. That is an important thing. If this temperature was in Celsius, degree centigrade or Fahrenheit, and the temperature is double, the kinetic energy will not double. But now because temperature was 200 turned into 400 Kelvin, if the temperature is double, the kinetic energy will also be double. So if it was EK here, it will become twice of this. That's why C is the valid answer. In this question, energy is supplied to a fixed mass of a gas in a container. The mean square speed of a gas is double. What happened to temperature? So what is the relation? We have the kinetic energy is proportional to temperature. The kinetic energy is half mv square. They mentioned this v square is double. Like this whole factor v square is double. So v square is double, the kinetic energy will also be doubled. Because they mentioned here mean square speed. They did not mention only speed. They mentioned mean square speed is double. So if mean square speed is double, the kinetic energy will also be double. If kinetic energy is double, what happened to temperature? That will also be double. That's why C will be the right answer. But what if the same question, instead of saying the mean squared speed, if they only mention mean speed is double. So if the mean speed is double, the kinetic energy is half mv square. The kinetic energy equals to half mv square. If I double v, what happened to v square? The v square will be 4 times, because like if v is 2v, the v square will be 4 times. So v square is 4 times, the kinetic energy will be 4 times. And if kinetic energy is 4 times, the temperature will also increase by 4. So it is important that you read the question properly, whether it is written mean square speed or they only mention speed. So if a speed is double, the kinetic energy will increase with a square. So it means it will become 4 times, so temperature will increase by 4. But if they mention only the square speed is double, it means this whole factor, is double. So that's why the kinetic energy is also double. So option C will be the right answer. So the graph is showing how the temperature for chocolate varies with time. Remember, the internal energy is a sum of kinetic and potential. So here in the beginning, the kinetic, because the temperature is increasing, so kinetic energy will increase, internal energy increase. Between X and Y, the kinetic energy is same. But what happened to potential energy? That is increasing as the particle move away. So the sum of kinetic and potential energy will increase, or internal energy will increase. Here also kinetic energy increases. So the internal, so all the regions, the internal energy is increasing. But we have to tell from X to Y what happened. The internal energy of a chocolate is increased. That's true because kinetic is not changing, but potential changes. Internal energy is not constant here, as there's a potential energy is increasing, so internal energy will also increase. The kinetic energy of a molecule in chocolate increases. That's wrong because the temperature is constant, so there is no change in kinetic energy. And the potential energy between the molecule and the chocolate stays constant. That's also wrong. As the particle move away from each other, so internal energy will, the potential energy will increase. So internal energy will also increase. So student carries out the experiment to measure the specific heat capacity of a block of aluminum. The value obtained by the student is less than the textbook. Look, the formula for specific heat capacity is how much energy we supplied divided by mass into temperature change. the more we are getting a smaller value. So in what case I can get a smaller value? If I measure the mass more, like overestimation of the mass is there, or if the temperature change is very high, or the energy supplied is very small. So these are the factors which can reduce the specific heat capacity. So if heater is insufficient, means we'll use the heater for a longer period of a time, so energy supplied will be higher. So this will increase the specific heat capacity. If the mass of a block is overestimation, is there like more mass, like what is the actual value, but you overestimate, like you use a higher value. As a result, your specific heat capacity will be smaller. If the thermal energy is transferred to the surrounding, so you have to supply more energy to reach a temperature change. So it will also give the higher specific heat capacity. Temperature scale did not start from zero. That does not affect anything. Like even it will not increase or decrease. So in this case, a mixture of helium and a hydrogen are both at 300. So if the temperature is same, the kinetic energy will also be same. So the kinetic energy of the helium will be same as the hydrogen. So average kinetic energy of helium molecule is same as hydrogen molecule. Their speeds will be different because the hydrogen is lighter, so its molecule will move faster. Helium is heavy, so its molecule will move slower. But the kinetic energy will be same.